Hello, learners. Hope you are keeping well. Today, we're going to look at some map work where we're going to look at the contours, and I'd like to get my highlight first contours and landforms. All right. And of course, I'm going to highlight the word map work. Okay. So, what we're going to do here, we're going to do it in three steps. First, we're going to look at uh, just a simple contour map to see how the landform is represented. Then we're going to look at a picture of the landform so that we can get a visual in our head of how the landform looks in reality. And finally, we're going to use the both of these, the simple contour map and the picture, you understand, to assist us to see how it's represented on the topographic map. All right, because that's what you're writing your exams on those topographic maps and, of course, orthophoto maps. So that is what we have to get to in the end. And don't just jump to the topographic map, get a clear vision of it, and you never ever forget it again. Okay, so let's get going. Some of these features you would have done already in terms of uh, grade 11 work where you looked at Mesas, Buttes, and things like that. And your teacher in grade 12 would have revised it to a certain extent or will revise it. Okay, so let's start off looking at a landform known as the Mesa. We know it's associated with horizontal landscapes. Okay, the few things we picked up is that when we look at this feature, the width is greater than the height. Okay, so that would tell us that it has a large flat top. Okay, can you see it there? And when we look at the contour map, we can see towards the center that it's relatively large area with no contour lines. So what does that tell us? That's the large flat top. Okay, and then we see here the lines are very, very close, showing you the steep gradient of this area here. Can you see it? And obviously it gets gentle, all right, as we move away from the cap rock here that's found right on the top here. We have a cap rock right on the top, okay, where it's very steep. Okay, and then it gets gentle. So we see it on the contour map. From a flat top where there's no contour lines, then we see as contour lines are close, which is steep, and then it gets gentle. Okay, so let's look then at how it looks on a contour map. Let me get my face away from the contours. Okay, now here you'll also notice in the middle here, okay, right, very little contour lines showing you the large flat top on a contour map. This one even shows it better, large flat top. And can you see what happens around it? Okay, it's steep, showing you that cap rock section. And then, of course, it gets gentle. All right, same here, steep, and then it gets gentle. Okay, so that's how you would identify it on a topographic map. All right, now, as I indicated here, the cap rock, steep gradient. All right, large flat top. Okay, so that's how you do it. And learners, you would know that you can be asked for reasons. Okay, identify the feature. All right. Ah, it's a Mesa. Why would you say? Because the top is relatively large. All right, large flat top. Okay. Now, let's go to the next feature. Oh, before we do that, let's do our summary. Apologies, learners. Okay, what was the Mesa again? It's an isolated flat topped hill with steep sides found on landscapes with horizontal land strata. Okay, you've done that in your theory. Of course, we said the width is greater than the height. That's what we picked up. It's a large flat top. Okay, large flat top. Contour lines are generally closer, and I'll move my face again, closer around the flat top as I showed you, indicating a steep gradient, all right, of the steep cap rock or hard rock there, all right. Okay, so it's the hard rock that makes the gradient steep because erosion is less. Okay, let's go on. Let's look at the Butte. Now you've done this in theory. All right, you can see there's a flat top or generally flat top. All right, and now you notice the height is greater than the width. All right, the height is greater, but the flat top is smaller compared to the Mesa, where the flat top was bigger. All right, now when we look at this, can you see the flat top is smaller? I just want to go back here. All right, quickly. Can you see how big the flat top is? All right, how big? All right, even down here, we see it clearly how big the flat top is, Mesa. But when we go here, you can see it's much smaller. Okay, that is your Butte. I call it the Butte. I know generally geographers say it's the Butte. I don't like using the word that much, but Butte is the correct word. I call it the Butte. Okay, right. Uh, let's go on. So we see that. Look at this, learners. Can you see the center now? You looked at the topographic map of the Mesa. It was much bigger. Can you see it here? The center where there's not much contour lines, it is smaller. All right. So the flat top on the top is smaller. I call it the flat top. All right. Not totally flat on most occasions, but generally flat. All right. And of course, the steep gradient of the cap rock here. And as we go down, you notice it gets more gentle. So both features have the cap rock, and that is why you'd have the steep gradient down there. Okay, is that clear, learners? You've seen that well. All right, now let us go on. All right, this should not be the Mesa. All right, it should be the Butte. My error while editing. Sometimes the gremlins creep in. All right, so it's the Butte or Butte, as most geographers say. Okay, the Butte. All right, so it's not the Mesa, it's the Butte. All right, so it's a large, flat topped hill. Okay, a tall flat top hill rather, because the width is not greater than the height. The height is greater than the width, so it becomes more tall looking. All right, steep-sided towers, same as the Mesa, found on landscapes associated with horizontal strata. You've done that in your geomorphology theory, but here the height is greater than the width. The height is greater than the width. Okay, learners? Opposite now. Mesa, the width was greater than the height. Here, the height is greater than the width. And of course, it has a smaller flat top. And the contour lines again are generally closer around the flat top, indicating steep gradient of the steep cap rock, or cap rock rather, right, which is a hard rock. Okay, so we identified both on the topographic map. Let's go on. All right. Let's look at the next one, a conical hill. You can see the cone-shaped hill. All right, I did exaggerate this to make it more cone-shaped. And you would notice this does not have the cap rock. Basically gone or very limited. Okay, so when you look at the contour lines, you don't see contour lines close around the top. It's further apart. Doesn't mean the gradient is not steep, it's relatively steep, but it's not just steep on the top and then it gets just gentle. Right? So this is how you would identify the conical hill, in the sense that it was not steep around here to show you the cap rock the caprock has been eroded. And I want to go back quickly, learners, all right, to show you this. All right, can you see here the steep place? All right, showing you that layer, that resistant rock layer where it's close. The cap rock is still there. Okay, can you see it? And I want to show you here. Can you see around here? The cap rock is still close. All right, the contour lines are close because cap rock is resistant, gradient is steep compared to the rest. But when we get to this, what do you notice? No, we don't have that steep and then just getting gentle all of a sudden. All right, it seems quite uniform down here in terms of the slope itself. Contour lines are like sort of evenly spaced out. Okay, that's how we differentiate between a conical hill and a mesa and butte. But enough said on that. Let's just do a little summary. All right. Well, first, let's look at the conical hill. Can you see it's not totally steep there as we go down away from it? All right. You can see around that center, no real steep gradient. All right. It is steep generally, but not steeper in relation to the rest. It seems like quite uniform there. Okay, that's how you would make out your conical hill. All right, this is gentler gradient in relation to the Mesa and the Butte. Doesn't mean it's gentle gradient. All right, gentler in relation to the Mesa and Butte. I'm going to say to the Mesa with the M and the Butte or but. All right, it's gentler gradient to that. Okay, are we clear with that? All right, let's go on. So we say the conical results from, and this is a little definition of it, results from the action of an entrenched river, which is cutting in, all right, that cuts deeply into a plateau. Okay, there's no horizontal cap rock. Okay, it's a gentler gradient compared to the Mesa and Butte at the top. All right, please note that doesn't mean the gradient is gentle. It can be steep, but at the top, it seems like a gentler gradient compared to the Mesa and Butte because it does not have the cap rock, the hard rock. Okay, we've got that. Then let's go on. Let's look at the saddle. All right, a saddle. Now I know when you think of a saddle, you immediately think of the saddle that you put on a horse. Right, the saddle you put on a horse, okay, and it seems the same. If you look at the shape here, you can see it looks like that. There's the sides here, and that's the middle, so it looks like that. And I think that is why it's called a sort of saddle feature. I don't know where it came from, whether the saddle on the horse was called after the geography or the geographical landform was called after the horse. But let's say we were more intelligent and we said it first. Okay, so what do we look at here? Let's look at this saddle. Is the lowest point along a ridge between two mountain tops. Can you see the mountain here and the mountain there? Can you see that here? Or hill? All right. Can you see this area? All right. Is steeper, and this area the same. Okay, the same here. And in between, the land is low. All right, it's a low point here. All right. So when we look at this, can you see the two hills? And in between is the saddle. Can you see it? All right, it reminds you of that, your pressure systems also, eh? You've got that little saddle there on your pressure systems when you look at your synoptic map. Okay, so let's go on. Let's look at it here. Can you see around here? This is the picture. All right, this is the picture. This is the high point, and there's your saddle in the middle. All right, the low point between the two. So that is why I'm saying, learners, it's so important to visualize it also before you look at the topographic map, to visualize how will it look in reality. And that's your saddle. Okay, So now let's go on. Can you see in the middle the low point between these two hilly areas? All right, can you see it here? And in between that, you have your saddle. That's how it look on a topographic map. Okay, now let's go on. Another feature, gap or poort. All right, gap or poort. All right, now this is a narrow pass through mountains. So you got the mountains, and in between the mountains, you got a narrow pass. Look at this hilly areas here, this mountainous areas here, and the mountainous areas here, and the mountainous areas here. And most probably a river now has cut right through that mountain, but it's relatively narrow. Okay, it's good as you'd learn later on for infrastructure to even build transport routes between that because of the mountains on both sides. All right, and then you have to travel around the mountains. You go through a gap or poort. All right, that is later on you learn about gap towns and whatever, but let's not worry with that now. Okay, right. So let's look at it now. Can you see here? There's your mountainous area. There's your mountainous area. And can you see in the middle? There's a gap here. See how nice to build a road, eh? Through that. Instead of going around the mountains, you can go through them. All right? Not right through the mountain itself, but the gap or poort through the mountainous areas. All right. Now let's look at how it looks on the map. I'm sorry, it's a bit blurred. I do apologize for that, but this is a nice one that I found. Can you see all the hilly areas here? All the hilly areas here. You can see even a river has went through. And can you see between this on the topographic map, it shows you the road. All right, I've exaggerated this. This is actually a main road cutting through that between those mountains. All right, the gap or poort. Beautiful for infrastructure to come through it also. Okay, that's how it look on a topographic map. Okay, let's go on. A gorge. Now, what is a gorge, first of all? It's a narrow valley between hills or mountains, typically with steep rocky walls and a running stream. So generally you have a running stream. All right, it's a running stream. So if you look at the contour lines here, can you see it's moving in? All right, there's a contour line showing you the steep. Obviously, the river would flow where it is going downwards. Remember the V shape. When you do the valley, it points, when in the valley, it points towards increasing height. So there's your river flowing down this steep gradient with the hills on both sides. Okay, so that's how it look on a contour map. I know this is a bit sharper image. It'll be a bit more windy, as I say, all right? But I'll show you on the contour map just now. All right, so let's look at it. Can you see the river here? And can you see the steep areas here and the steep areas here? That's how it looks in reality, your gorge. Okay, so that is your gorge coming through there. People are enjoying themselves. That's definitely not me, okay? Uh, but they are enjoying themselves there. Okay, that's your gorge. All right, let's look at it down here. Can you see? There's your steep areas getting steeper and steeper. Can you see it? And there's your river flowing through. This is how it would look on a topographic map. You may get a better one, okay, in your examiners where it's clear, where it shows you even steeper gradients, all right, but it's flowing through the hilly areas, all right, your gorge itself. Okay, right, now let's go to the next feature, a waterfall. Right. Now you learned a cascade of water falling from a height formed when a river or stream flows over a steep incline. So suddenly, as you've learned, There's your thing, and suddenly it comes down and the water falls over that. I suppose that's why we call it waterfalls, eh? Because of waterfalls. All right. So it comes down. Now look at this point. Can you see how steep it is there? Contour lines are very close there. Obviously, that would be your waterfall. Okay, your waterfall itself. All right, learners, that's how it look on a contour map. On a topographic, oh, well, let's look at our feature first. Oh, this is a fantastic feature, eh? The waterfall itself. Beautiful. Very good aesthetic appeal. But you can also see the steep gradient here, eh? Compared to here, suddenly we got the steep gradient. And that is why on the contour map, it showed you the contour lines are very close. Okay, so we have the steep gradient there. Right, let's go on. Can you see? This is how the symbol shows you where the waterfall is on the map. It makes it quite simple to identify. Okay, because generally it's written on the map, waterfall. Okay, it's associated a lot with change in gradient, with things like rejuvenation. Okay, because that comes through. All right, if you don't know, if you're low in grade 10 and 11, you don't know about rejuvenation, don't worry about it now. It's more for the grade 12. All right, tells you about rejuvenation, etc., happening in those areas. Okay, grade 12 is only that. Eh? Grade 10, 11, don't get worried about it. Okay, a cliff, a steep rock face, especially at the edge of the sea. Doesn't mean you only get it there. You can get cliffs anywhere. It's a steep rock face, steep, coming down. Okay, and you notice it here. Look at the contour lines very close there. All right, very, very close. That is your cliff, a steep place. All right, when I show you a picture now, it'll be easier. Can you see it here? Steep, almost vertical or vertical. All right, but very, very steep. All right, can you see it? Right through here. That's your cliff. Okay, now when I looked at this area, this is the Table Mountain region. Can you see this area where the contour lines are very, very close? All right, that could be an example of your cliff. Very steep territory around the Table Mountain area. Steep gradient, contour lines very, very close. Okay, let's go on. A valley and spur. I know you may be tired of this now. From lower grades, you've been doing it. You know a valley is a low area of land between hills and mountains, typically with a river flowing through it. Not always, but the river is generally flowing. All right, so it's a low area. Can you see it down here? All right, your river valley. And of course, you know you can identify the topographic map because the V shape points towards increasing height if it's a river valley. And remember, then the river flows downwards. All right, can you see the V shape of the contour lines points to increasing height? Then here in the spur, you'll notice the opposite. The V shape points towards decreasing height. All right, so this would be your spur. Lines, V shape of contour lines point towards decreasing height. Okay, now that's our contour map. Let's look beautifully. There's your high areas, your spurs. There's your river valley. Beautiful scenery. South Africa has fantastic sites. All my sites generally that I use are from South Africa. We have beautiful natural areas in the country. Eh? So next time, learners, instead of when you're going on holiday, don't talk about Durban, Cape Town, and the CBD and the nightclubs. Go and visit this beautiful natural environment. It's far more beneficial with a lot of aesthetic appeal. But anyway, let's get back to the lesson. All right. Okay, so we look at it here. Can you see, learners? The V shape here will be pointing towards increasing height, the V shape, and that's your valley, your river valley, and easy to identify also if there's a river there. Okay, it's easy. You don't have to look at the contour lines. As soon as you see this area with the river in it, you know that's a river valley, all right, or the valley. And then the area next to it would be the spur. So that's one of your best ways to look at it. And you can already work out these V's are pointing to decreasing height, this V's are pointing to increasing height. But that's how it would look generally. But don't take it for granted that you may have a river there. Okay? But generally you have a river, and that makes it easy to identify on your topographic map. Okay, then let's look at some ridges. Let's add this into. We can identify ridges. All right, you've learned already that the Cuesta, of course, if you're in grade 10 learners, you haven't touched this. All right, and I want to warn grade 10 learners, the Mesa, Butte, etc., you haven't touched this. All right, so if you want to watch this video out of interest, you will learn. Okay, but the river and valley is yours. So the Cuesta we learned is between 10 to 25 degrees. Okay, 10 to 25 degrees. So that is not so steep. It just dips between the angle of 10 to 25 degrees. All right, dips at an angle of 10 to 25 degrees. Okay, and then the homoclinal ridge dips between 25 to 45 degrees, dips at an angle of 25 to 45 degrees. Can you see the angle is getting bigger? So the slope here, the dip slope, which is the gentle slope, is relatively gentle compared to the scarp slope, which is the steep slope. Here, the dip slope is not as gentle because the angle has increased. And eventually, when we come to the scarp slope, the angle is greater than 45 degrees. Okay, greater than 45 degrees. All right, and if you look at the difference between the spacing here in the contour lines, you will notice this. I'll talk about that now. So the angle gets bigger, and that's it. Now, hint here, if you look at the difference in the spacing between contour lines of the dip and scarp slope, it will make more sense. Like, for instance, this one may have contour lines like this, and then you may have your high area, all right, the ridge, and then you may have your dip, your scarp slope like that. Can you see it? Very, very close. And this one, there may be a difference now. Let's put your middle there, right? And now your dip slope may be, can you see that? What happens to the dip slope? The contour lines are closer, and of course your scarp slope will be close. Okay, and then of course with this one where there's not much difference between the dip and scarp slope, let's put our middle area, all right, and then we say there's the contour lines. Okay, make them closer and closer, and of course that's your dip slope, and there's your scarp slope, right? And there's no real difference. So this is what we're saying here. Look at the difference in the spacing between the contour lines of a dip slope. You will see the spacing is different, massive difference in spacing. Gets a bit closer on the dip slope compared to the scarp slope. And yeah, there's hardly much difference. And if you look at those contour lines, you'll be able to make the difference between the ridges. Okay, so let's go on. Now, if you look at the Cuesta, can you see here? Learners, look at the dip slope. Contour lines are relatively more, quite far apart compared to the scarp slope. That's a dip slope, that's a gentle slope. All right, can you see it here? Also far apart. That shows you quite a gentle dip slope compared to a relatively steeper scarp slope. Can you see it? Far apart. Okay, far apart down here. All right, so we've got that. Right, now let's look at the pictures again. Can you see? Big difference between the dip, which is gentle, and the scarp, that's your Cuesta. All right, and then we go to your Homoclinal. There's a lesser difference. That one was far more gentle on the Cuesta. Yeah, the gentle slope is a bit more steeper compared to that one. All right, and then eventually we come to the Hogsback, where you can't really make the difference between the dip and scarp slope because the angle is 45 degrees. So anyway, let's take an example now. All right, let's take this. If you look on this side, contour lines are close, your scarp slope. Look at your dip slope. They're relatively further apart, quite a distance apart. So we look at this and it'll be your Cuesta. But let's take an example of another one. Yeah, it's close. Yeah, you can make the difference between the dip and the scarp slope. But if you look at these lines, they're much closer compared to that lines. So therefore, it'll be your homoclinal ridge. But if sometimes it's not very clear where you see the distance apart, all right, then look carefully and you can call it a homoclinal ridge. All right. And of course, if you take a uh, Hogsback, the lines will be so close you can't really make the difference. But I just showed you the homoclinal and the Cuesta as that. But if you stuck and if you learned well and it's not really clear, then go with the one homoclinal ridge. All right. And if the examiners see that it wasn't very clear, they will take the answer of the homoclinal ridge. Here it is very, very clear. All right. When you see the difference, that is definitely far apart. All right. Compared to this one. Okay. And that is your ridges. All right. So this is more your grade 11, right? And of course, Mesas and Buttes, etc., your grade 12. So I do apologize to grade 10 learners. Okay, it's just your valley and your spur, etc., and not so much of the other features. Okay, right. Let's look here. The beauty part is you've done slope elements in grade 11. All right, slope elements, and you can actually determine the slope elements on a topographic map. Beautifully, you can do it in an orthophoto map. All right. So if we look at this little feature here, you can see on the top, it's gentle. All right. And of course, if you draw a cross section of this, it'll result in a concave slope. All right. A convex slope, rather. I apologize for that. All right. That is your crest. And you'll notice next to it, the steep rock. All right. That will be your cliff. And then you notice it's a uniform slope. Can you see the contour lines are evenly spaced here? All right, and that's your talus. And of course, it's much further apart here, and that's your pediment. Can you see it? We can actually do a lot on a topographic map. All right, so sometimes we just say slope elements, look at that word slope element, say, let me see. All right, let me visualize a cross section of it. All right, so let's look at that. Let's do a rough cross section of this. All right, this is just a rough cross section. All right, let me get my slide. Can you see? There's your trig beacon 46, and there's on dry, and there's your crest down here, as I showed you on the topographic map, your cliff, your talus, and there's your pediment, which you learned in slope elements. All right, and now you can apply it here. Okay, so it's brilliant that what we can do with a map, a flat piece of paper, which is really alive. Can you see it there? Brilliant. All right, let us go on. And then we look at a granite dome, and I must move my face again. All right, when we look at a granite dome, we already know a granite dome. It's domical hills, dome-shaped hills, composed of granite with bare rock exposed surface, right, over most of the surface. You get some vegetation, etc., but generally most of the surface is bare. Okay, there you can see this massive granite dome here. This is the Paarl rock. Beautiful rock found in South Africa again. All right, and you can see the contour lines all around. It's quite close, quite close. And this is how it would look on a contour map. Okay, areas around it is close contour lines. All right, showing you it's quite steep, but it's domal. And you can see a more or less domal shape here. Can you see it, learners? It's a more or less domal shape. All right, so it's a granite dome. Of course, another thing you would look at here, the height would increase towards the center. Watch out for that, because if the height is decreasing towards the center, it can also be a basin. Watch my hands, basin. All right, like your washing basin. That's not round in most occasions, but it's a basin. All right, so watch out. The height must also increase towards the center. And this pile rock is a good example. I've got a little diagram. You can see the hilly area around this place, eh? And this is the symbol. You look at it on your reference, you'll find there's a simple symbol for the power rock. But you can see it's relatively hilly around the place, all right, of power rock. All right, that's how it will look there. Okay, let me carry on. And then a plain, which is a broad area of relatively flat land. A broad area of relatively flat land. That's a plain, it's flat. All right. Okay, you can see there, relatively flat land, a broad area. All right, later on, if in grade 11, in grade 12, you learn about a flat plane. All right, this could be a flat plane. All right, but it's a flat area. Okay, here we can see a plane, huge flat area. All right, that's found in a place. Okay, then if you look at this area, it's gentle. All right, so this could be considered a plain, a flat area. All right, that's how it look under topographic map. All right. Sorry, learners. That's the last slide. I was enjoying myself so much that I even want to do more. I know you've done certain features in grade 11, grade 10s. View it. All right. I think the valley and the spur is something that you can identify, but many of the other things you can't, because it's from grade 11 onwards. Lots of these features, grade 11s, is yours. You've done ridges, you've done slope elements, you've done mesas and buttes. Grade 12s, you know your structures of mesas, buttes, conical hills. You understand that you can use. Of course, I've done a lot of features for both 11 and 12 and very tiny for the grade 10s. So when you watch this video also, please keep your curriculum or your guideline to see which features that you're going to deal with. Okay, for that. All right, but it's a general thing that covers more 11 and 12. All right, but I hope you enjoyed it. And remember, map work, how it looks on a contour map, how it looks in real life, and then you take it towards the topographic map. And you should not have problems. It becomes so much fun to identify those things. Okay, learners, I hope you enjoyed. I hope it makes it clearer for you. All the best and goodbye.